Hello everyone, welcome back. We're at lesson 10 of the Math 10C course. That means we're almost done. We have 2 more lessons left after this one. Wow, we're going strong. So this week we're going to start a new unit called linear functions. We're basically going to be exploring the slope of a line and then something called slope-intercept form, which is one of the 3 forms that we'll be learning in Math 10C. And the second one is slope point form. The third one we'll learn next week, and that is a bit more different than these ones. But let's get started. So, a slope of a line, the technical definition is it's the change in y divided by the change in x. So y refers to like the y axis coordinate points, and the change in x refers to the x-axis coordinate points. So over here, this is the equation for it. It's the change in y. So this triangle thingy that you see here is actually the symbol for change. It's called delta. It's a Greek letter. Greek letter delta. Delta. It's used a lot in math. Like it doesn't usually means change, but yeah, it can symbolize other things as well. This basically means change. Awesome. So, in an equation for a line, the slope will always be constant. Like sometimes if you have a curve, then that's a bit harder to calculate, but in a line, you calculate the slope, it's constant, it's going to be the same slope throughout the entire line, no matter where you are. So what I like to think of it as, or what most teachers like to think of it as, is rise over run. Think of it like this. When you have a line, and you want to calculate the slope, right? The formula looks like this. It's the y value divided by the x value, right? So the y value is how much you go up, so how much you rise. And the x value is how much you go across, which can also be how much you run. So when you put it together, it would be rise over run. Rise divided by run. So let's go back to talking about the formula. How do you calculate change? Well, I have it over here, so don't look here. It's a bit of a cheat, but to calculate change, you need to subtract. Let's see. You first have to pick 2 points on the graph. Subtract the y value, the first y value from the second y value, and then do the same thing for the x, and then you divide it, and you get the slope. So let's try an example. So over here, I've got the formula out here, the formula for slope, and I have a sample line that we want to calculate the slope for. Over here, we're given 2 points, and we want to calculate the slope. So it's quite a simple matter. We remember that m is equal to rise over run, which is equal to y2 minus y1. Oh, by the way, m is the symbol for slope. It's French, I believe. I believe it's molt. It comes from the French word molt, but yeah, I'm not certain on that. Anyways, let's try to calculate the slope of this line. So we're given 2 points. Let's write down the formula. M is equal to rise over run. So y2, our y2 value, the y values I'll highlight in green. It doesn't really matter which one you pick as your first and which one you pick as your second, as long as you're consistent with it. What I mean by consistent is that you see how the x also has an x2 and the next one. You can't flip these 2 values. So let's start. Over here, I have y2. Let's pick this as 0.2. And let's pick this as 0.1. P2 and P1. I'm just naming it. You don't have to, but our y value is 3 on P2, and it's -1 on P1. So remember, whenever you have a negative minus a negative, you add. Let's finish writing it down first. The x value for the second one is -3. The y value is 3. Okay, And then we just simply subtract. 3 minus -1 is 3 plus 1, which is 4. And -3 minus 3 is -6. So this seems to be our slope, but we have to simplify our fraction. So 4/6 can be simplified further to 2/3. Also, it's kind of conventional to put the negative on the top, on the numerator, just because, well, it's for a calculation, like the ease of calculation. It's pretty much just conventional. You'll get used to it. But this is our final answer. This is our slope. So what does it mean when it says that our slope is negative 2/3? Well, whenever the slope is negative, we'll talk about it in the next slide, but whenever the slope is negative, it's kind of like going down, which is true in this case. This line is going from the top left down to the bottom right, right? And then this 2/3 basically means, remember, slope is equal to rise over run. It goes down 2, so it rises -2, and runs 3. So let's take a look at the graph. Oh no. Let's start from this point. If we know that the slope is down 2, we know that it goes down 2 first, and then it runs across 3. So the slope continues just like this. Oops. Continues like this all the way, well, perpetually. So this is basically what our slope looks like. Okay, so I'm going to talk quickly about horizontal and vertical lines. So in the case before, it had a slope, right? But if we have a horizontal line, will a horizontal line still have a slope? Well, as you can see here, yes, it'll have a slope, but that slope will be 0 because it's not rising or running anywhere. It's staying constant, right? The rise is 0, the run is, well, infinite, but if let me write this down. The rise m is equal to rise over run. In a horizontal line, the rise is 0. This is a horizontal. Rise is 0. The run is infinite, but whenever you have a fraction with the numerator 0, it's basically 0. So that's why the slope is 0. Oh, I shouldn't use an h. An h can be a different variable, so use m of h. But in a vertical line, so m of v, the rise, it looks like this, right? So the rise is infinite, and what is the run? Well, as you can see here, it doesn't actually move. It doesn't go anywhere. So the run is actually 0. But this is where you run into a problem, because whenever you have a fraction that has a 0 as a denominator, while the value is considered undefined. What does that mean? Well, it's basically just not possible because you can't divide a number by 0. It's not possible. There are many proofs, and yeah, you'll be able to study them a lot if your teacher takes an interest. But yes, this would be undefined. Oh no. Let's just keep an eye out for that. Okay, so let's talk about slope-intercept form. Slope-intercept form is one of the 3 ways to represent a linear line. We'll talk about 2 of them today and the 3rd one tomorrow. So a slope-intercept form is a linear equation written in the form y equals mx plus b. You may have heard this. This is a pretty famous equation. It's pretty universal. The m is the slope, which we kind of talked about before, moles, and the b is the y-intercept. I know it really doesn't make sense because, like, what does b have to do with y-intercept? But yeah, they just use this value. You'll actually see later that it actually makes more sense to use c instead of b when we talk about the third way of writing the general form. But we've kind of got stuck with this, so we're just going to use this for now. This form makes it easy to find the slope and the y-intercept, and that is why it's called the slope-intercept form. Over here, I have a YouTube video kind of talking about it. You can watch it in your own time, but yeah, it's a pretty good YouTube video. It's very helpful. I'm going to move on to some practice questions. So over here, I have a lot of equations. I have a lot of equations for us to work with. They are equations of lines, and I want to find the slope and y-intercept of each equation, each line. So let's give it a shot. Remember from before, y is equal to mx plus b, right? That was our formula, our formula for the slope-intercept form. Y equals mx plus b. What was m? M was the slope, and b was the y-intercept. So we don't even need to do anything here. We literally just need to look at what the values are that are beside x and beside or not beside, sorry, the constant. That's literally all we have to do. Once we find them, we can just bring it out. The m value is equal to -5, and the y-intercept is equal to +4. Same thing for the rest of them. We can do another example. Over here, we have a slope of -3 and a y-intercept of +1. By the way, a y-intercept, have we talked about that? I believe we have gone over it, but very briefly. The y-intercept is basically just, oops. The y-intercept is basically just the point where the line crosses the y-axis. It's the point where it intercepts the y-axis, which is why it's called the y-intercept. Surprise. Not required, but let's try graphing these, like sketching it out, not graphing it. But okay, so these ticks are, I'll assume, going up by 2, just for ease of, well, looking at it. So if our slope is -5, negative, note that it's negative, that means it's going down, downhill, it's a downhill slope, and our y-intercept is at 4, which is somewhere around here. Let's kind of sketch it out. It is going to look something around like this. I'm not sure if it does cross at 1, but it'll look something like this. And similarly, this one is also a downhill slope, and it crosses at 1. So it'll cross a bit closer to the x-axis, something like this. It's not to scale, obviously, and this is a really rough sketch, but it'll look something like this. The next one, pretty similar. I mean, it is the same thing. Just look for the slope and look for the y-intercept. This one is actually in the negative, so -1.25. So it'll actually cross at the bottom below the x-axis. Okay, so now let's do it in reverse. We are given the slope and the y-intercept, but we want to find the formula. So using the same formula, y equals mx plus b, and inputting in these values, we can simply get y equals, the m value is -6, and the y-intercept is 2, +2. Okay, same thing here, but notice how the slope is 0. What can we tell before we even write out the equation? I'm gonna hop back over to one of the previous slides. Highlighting this point. So our slope is 0, which means that it is a horizontal line. It doesn't rise anywhere. So it stays flat the entire time. and our y-intercept is at -3. Well, what does this tell us? If the line crosses the y-axis at -3 and it doesn't run at all, that means it's going to be a straight line at y equals -3. So let's just input in the point so you can see what I mean. The slope is 0 and the y-intercept is -3. This 0x would cancel out because anything times 0 is just 0, which is pretty redundant to keep it there. So our final answer would actually be y equals -3. Okay. Now we have a few more questions. Oh no, what happened here? Okay. Quite a mess. I'm rearranging. Okay, so I have a few more equations that are not in the slope-intercept form, but I want to put them in it. So let's do some rearranging, some quick algebra with these. So over here, I have 2x plus y equals 6. So remember the form that we want to get it to, right? We want it to be in the form of y equals mx plus b. So that means we first want to isolate the y. So let's do that. I will bring the 2x to the right. So I'll subtract it from both sides, which gives me y equals -2x plus 6. And is that in the form y equals mx plus b? Any further rearranging needed? No, this is perfect. We're done. Next one, this one looks a bit more messy. So once again, let's try isolating the y first. It looks like we can just bring the y over to the right side. So 7x, we'll add y to both sides, which would give us 7x plus 9 is equal to y. All right, we're making pretty good progress. This is also already in y equals mx plus b form. Yeah, you can flip it if you want the y to be on the left side. It doesn't really matter. But now we have something that looks a bit more complicated because this time there is something on the y. There is a coefficient. So we will probably, okay, let's just isolate the y's like we did before. So I will add 4y to both sides, which will give me 8x equal to 3 plus 4y, but y isn't isolated yet. We want to get rid of the 3, so let's subtract it from both sides. I should use a different color so it's easier to see. It's just algebra at this point. Goes 4y. So now y is almost isolated, except there's still a pesky coefficient attached to it. So what we need to do is divide it. Divide the entire equation by 4. And this will give us 8 divided by 4 is 2x minus, now here's something that's a bit tricky. Don't forget to divide the -3 by 4 as well. You can't just have a 3 here and be done with it because you haven't actually divided it by 4 yet. So you do need to put it as a fraction. It's 3 over 4. You can put it as a decimal, but teachers will prefer fraction form because it does make yeah, in high school math and later math you do want to leave your answers in fraction. That's it. Y equals mx plus b. Perfect. Moving on. Okay, so finding the b value. Sometimes you're given an unfinished equation that you need to solve. So let's try. A line has the equation y equals 3x plus b, so notice how we're not given the b value. What is the value of b if the graph of the line passes through 3, 1? So we are given an unfinished equation and a point, but we need our equation. In order to complete our equation, we need the m value and the b value. We do have the m value, it's 3, but we don't have the b value, so we need to calculate that. Thankfully, we do have something that we can start with, a point. We can actually, so we're given the x and the y values. The x is 3, the y is 1. So we can actually input these values into this equation, which will look something like this. So the y value is 1. It's equal to the x value, which is 3. Oh, oops, I forgot to put the slope. Plus b, we don't know b. I should probably erase the brackets around 1. It looks like 101 over here. This is just 1. Okay, so let's just do some algebra. Let's simplify everything first. So 3 times 3 is 9 plus b. So now we can bring the 9 over by subtracting from both sides, which will give us -8 is equal to b. But we're not finished yet because we actually still have to put this value into our equation. That's when we actually finish. So let's bring it back to our original equation, which was y equals 3x plus b. And we now know our b to be -8. So we can just subtract or erase that positive. And this is our final answer. Yay! Okay, so now slope point form. This is a second way to represent a linear line. So slope point form is a linear equation written in the form y minus y1 is equal to slope times x minus x1. It's a bit more complicated than the first one for sure, but this form makes it easy to find the slope using 2 points from the graph, because sometimes you're not given the y-intercept. Maybe you'll be given 2 points instead. So if we want to complete an equation, we would have to find the slope using that. So yeah, I have an example over here. Find the slope of these equations given 2 points of the graph. So we have the equation, which was, what was it? Y minus y1 is equal to times x minus x1. This is our equation. And we are given 2 points, and we want to complete this equation. But we don't have the slope, so we need to calculate the slope. Okay, so let's put these values in. We have 2 different points, which is perfect. The x value I've highlighted in purple, pink or purple, and I'll highlight the y value in green. So let's put these in. Once again, it doesn't matter which you use as the first point and which you use as the second point, but I'll just use the first point that we're given as the first point. So the y value of the first point is 2, minus the y value of the second point, which is 4, is equal to slope, which we don't know, times x of the first point is 3, and x of the second point is 4. So now, once again, let's kind of work with this. Remember bed math. So what most people are tempted to do is just, multiply this in, but we have to do the brackets first. So on the left side, it doesn't matter because there are no brackets, so we can just do the equation, which is just 2 minus 4, which is -2. But on the right side, we have to do the brackets first. 3 minus 4 is -1. Okay, so now we have -2 is equal to m times -1. We still haven't isolated the m yet, so let's just divide out the coefficient of m, which is -1. To divide it out, we can just divide the entire thing by -1. And when you have -2 divided by -1, it becomes +2. And that's our final answer. The slope of this equation is 2. Okay. The second one, same thing. Go just put the points into the formula and find the slope. But kind of like, let's do a part B of the first question. So we have the slope, but now let's put it into the equation and find the proper equation for the first point, for this line. So using point slope form, we have y. Maybe I shouldn't use orange. We have y minus y1, which we can use any point, it doesn't matter. Let's just use the first one. Y minus 2 is equal to m, which is 2, times x minus 3. That's the point slope equation for this line. Yay. Okay. Now comes something I don't want to say more difficult, but it's definitely more time consuming. We have to be able to convert between point slope and slope intercept. Go back and forth between the two. And later on, once we learn the general form, we also need to learn how to convert between that as well. So converting it sounds scary, but it's really just a matter of rearranging the numbers. So we want to get from over here, we're given the equation in point slope form, right? But we want to get to slope intercept, right? So my point slope to point intercept. This is the point slope formula. And we want to get to the slope intercept, which is y equals mx plus b. So let's do that. Over here, in slope intercept, the y is isolated, which is different from point slope. So let's start off by isolating the y. To isolate the y over here, we just have to take out 4, which would give us y is equal to 2x plus 3 minus 4. Is this the form that we're supposed to be in? Well, we're getting closer, but this over here has to be distributed. We have to get the x out of the brackets. So what we can do is use something called the distributive property, which you've likely worked with before. I believe we did talk about it in a past lesson. So let's do that. In a distributive property, using the distributive property, you just multiply 2 with x and then 2 with 3, which would give you y is equal to 2x plus 2 times 3 is 6, and then minus 4. Now we're looking even closer to mx plus b, except one final step, we just need to combine these because they are like values. We need to always combine like terms. So we have positive 6 minus 4, which is positive 2. And that's our equation in point slope form. Same thing for the other side. This is something for you to practice. And I believe this is it for the lesson. Thanks for tuning in today. This chart it's like an overview of what this unit will look like. So today we talked about slope intercept. I'll check that off. We've talked about point slope. We haven't yet talked about standard form. We'll do that next week. And intercept form, this is not something that you need to know for the Alberta 10C curriculum, but it's basically a form which makes it really easy to find the x and y intercept. There are lots and lots of forms, like you can rearrange it in any way and that could still be a form. But yeah, we don't need to know this, and this is for next week. So we've also talked about vertical and horizontal lines. And that's it. Yay. Yeah, hope to see you all next week. Thanks so much for tuning today, and the recording will be posted on the YouTube channel, so keep an eye out for that. That's all. See you next week. Bye.